Okay, so this is 3.3a, piecewise defined functions and power functions. Now, most of you have done piecewise defined functions before, and I don't know if your teacher was good at explaining this or not. I know when I took these classes when I was a heck of a lot younger, like 37 years ago, I had my first college algebra course, and I did not understand this piecewise function stuff. It just did not make sense. And that was one of the reasons why I became a math teacher, is because I got tired of these math teachers that were so incredibly smart that nobody could understand them. So I just figured, I'm dumb. If I can get through this, maybe I can explain it in such a way that students can better understand this information, because I have a simple mind. And golly, I don't know if you can understand it better with me or not. But anyway, I think at least I talk from a perspective of not being a genius, because I'm not. So hopefully I can explain this in such a way that you can understand it. So piecewise functions are functions that really can't be defined or explained using a single equation. Okay? So basically what happens is there's different parts, and you use different formulas based on the information given. So let's look at, and I'll get into this a lot better once we get into some different piecewise functions. But if you look at example 1, you've got the price paid for a first class letter jumps by 21 cents for each ounce after the first ounce. Okay, so it does not increase until the weight increases by 1 ounce. Okay, so look at what we've got here. We've got 49 cents if the letter is between 0 and up to 1 ounce. So x is less than or equal to 1 ounce. So the price anywhere between 0 ounces and 1 ounce, including 1, is 49 cents. Once we get above 1 ounce, but we're still at 2 ounces or less, the price is 70 cents. Once we hit 2 ounces and go up to 3, it's 91, and 3 up to 3.5 is $1.12, so, or 112 cents. So the price change is different depending on how much it weighs. It is a constant with discontinuous steps at x equals 1, 2, and 3. So if we change from 0 to 1 to 2 to 3, the price difference is kind of goofy. And this is a special piecewise function, which I don't understand why they're doing special piecewise functions when they haven't really explained regular old piecewise functions. But anyway, this is called a step function, because see what happens? As we increase the weight, x is the weight of the letter, what happens to the price? Well, obviously you don't have something that weighs nothing, so they put a circle there to show that it doesn't include nothing. And as the weight increases to 1 ounce, then the price is the same, 49 cents. Once we hit 1 ounce, or once we go above 1 ounce, we jump up to 70 cents. So again, it does not include the 1 ounce, because the 1 ounce is included down here. So anything above 1 ounce and all the way until, that was a funny way to say until we get to 2 ounces, and then it jumps up to 91 cents. But not at 2 ounces, at anything above 2 ounces. And then that goes until it jumps up to $1.12. And then it goes that way until we get 3.5 ounces, and then we don't know what happens. But this is a step function because the price stays consistent until the next step, and this being the next step. Bonk, goes to a next step. 91 goes to a next step, goes to a next step. So it's kind of like a stair step here. So that's a special type of piecewise function that we're getting rid of right now. And that brings us to some regular old piecewise functions. And let's look at what it looks like. This is what a piecewise function looks like. F of x, or remember I said it was basically another way of saying y, equals 5x plus 2 if the number that we're plugging in for x is somewhere between 0 and 3. We use this equation if our number that we get for x is somewhere between 3 and 5. Okay, so we have two equations here, and we use each one depending on what value x is. If x is 0, 1, or 2, or any fraction up through 3, but not including 3, we use this equation. And then once we get a whole bunch of numbers plugged in here, we end up with an equation that looks like this right here. So this right here is the graph for 5x plus 2. This here is the graph for x cubed. Okay, so when x is somewhere from 3 to 5 inclusive, see, 3 closed circle, 5 closed circle. So we know it's this one, and it jumps up quickly. Okay, so we use that fraction. So in fact, I've got over here this table where they plug in numbers here, plug in 0 for here, and what do we get for a y value or an f of x? We get 2. We plug 1 in there, 5 times 1 is 5, plus 2 is 7. Plug in 2, 5 times 2 is 10, plus 2 is 12. So we can graph that and get this right here. And then when we hit other numbers that are between 3 and 5, we put 3 in. 3 cubed is 27. We put 4 in. 4 cubed is 64. 5 cubed is 125. And it jumps up real quick. So that's the solution to the piecewise function that we have right there, because it says graph. Okay, so I'm not going to do all the work for this example 3, but it's a typical residential power cost that when you are getting an electric bill, they charge you a certain amount of electricity. They charge you a certain number of dollars depending on how much electricity you use. So for this one specifically, let me make it bigger. If you use from 0 to 650 kilowatt hours, it's going to cost you $7.50 plus this amount of money per kilowatt hour. So you're going to take $7.50 plus this times the amount of kilowatt hours you use up to 650. So the equation for this would be $7.50 plus the amount of extra here times how many kilowatt hours you use, and that was from 0 to 650. So from 0 to 650, your x is going to fall in between there, and so your number of kilowatt hours, that's your formula for that. Now if we go from 650 up to 1,000, 650 up to 1,000, and including 1,000, and this is more than 650, so it's going to be greater than 650 with no equal sign under there. This is the formula you're going to use. 3440 plus 0.3946 per kilowatt hour above 650. So anything above 650 kilowatt hours, you're going to pay that per kilowatt hour. So it's 3740. That's just the standard number that you're going to pay no matter what, plus this number above 650. So that is making sure your hours are above 650. So x minus 650. And very typical for the bottom one right here. You're going to use this one here. And again, this is above 1,000, so it's going to be x minus 1,000. Okay, so here is example 4, and let's see what we've got going on here. Wind chill factors are used to measure the effect of the combination of temperature and wind. It's kind of like temperature and humidity. And there's our piecewise definition. So V represents the wind speed. So when wind is between 0 and 4, we use this equation, which is not an equation, it's just a number. So if the wind speed is, say, 2, it's going to go here. That means that the wind chill is 30 degrees, because this is for a 30-degree temperature, which basically means when the wind is below 4 miles an hour, it's not going to give you a wind chill factor. Okay, it's only when it's above 4 that it's going to do anything. So when the temperature is between, or the wind speed is between 4 and 60, 55.9, we're going to use this equation to find out what the wind chill is. When it's greater than 55.9, the wind chill is automatically at 30 degrees, negative 6.5. Okay, for any number above 55.9. Wind chill, negative 6.5 on a 30-degree day. But if it's between 4 and 55.9, we're going to use this formula right here, and we can get a different wind chill at 30 degrees, depending on how fast the wind goes. All right, so if we have a 30-degree day and the wind is 40, 40 falls in here, so we're going to use this equation right here. And notice that's what they did here, is they used this formula here and found out that the wind chill is negative 5. Okay, they did the same thing for any of the other ones they gave you. C, graph the function for 0 is less than or equal to v, which is less than or equal to 70. And that's what they did here. They gave you the graph here for the wind when it is between 0 and 70. Okay, so just kind of depends. Remember here, 0 to 4, it didn't do anything. It stayed at 30. But as it got windier and windier at 30 degrees, it's getting colder and colder and colder until we hit a wind chill of 55.9, and then it stayed at negative 6.5 forever. It just goes along this way. So the only time it really changes temperature is right here. Okay, so go ahead and read the solution here, read the D part here, and we'll call that one good. Okay, so here's the solution for example 5. The cost of weekend service calls by AirTech Services is shown by the graph in figure 3.27, right there. And you are supposed to write a piece-defined function that represents the cost for service during the first 5 hours as defined by the graph. Okay, so you're responsible to write the piecewise function like that. Okay, so there's 3 pieces to the function, there, there, and there, so that helps you. There's 3 equations, and you're looking for cost. So that's why they use C. And what else do they do here? For t values between 0 and 1. So remember, time is usually along the x-axis, along the horizontal one. What happens? Between 0, let me get my arrow. Between 0 and 1, the cost is the same. And does that include 0? Can't really tell if that's open or closed. Okay, that's an open circle. So that's why they have 0 is less than, rather than 0 is less than or equal to time, which is less than or equal to 1. It's closed here. And it's 330. That does not change. Any number between greater than 0 and less than or equal to 1, it's going to be 330. And then it says 550 for t values between 2 and 5. So again, if we have a closed circle here, we're almost always going to have an open circle in the next step because it includes the one here. It doesn't include it here, and that wouldn't work to have them both be included, because if it included both of them, then you wouldn't know whether you're paying 550 or 330 since they are both included. And And I don't mean to confuse you anymore, but if that were closed, that would make this, using the vertical line test, not a function because our line would go through both that point and that point. And when, this is all free information that the book doesn't talk about, when this is a closed circle and this is an open, there is not actually a point here. This is not a point on the graph, okay? So that means when you draw a vertical line, it is not going through a point on a graph until right there, and it only goes through one. This is not a point. This is not a point. So therefore, it remains being a function. So it works. So just something to remember there. All right, so it's between 2 and, or 1 and 2 here, and it's 550. 770, if we look at this, it starts at 2 and goes to 5-ish. And so there's your equation there. It does not include 2, it does include 5, and it's 770. So there's your piecewise function that is fairly easy to write given the graph. I mean, you're just reading the information here, looking and saying, well, there's 3 breaks here, so therefore I have 3 different functions there, or 3 pieces to the function, I guess is what I should say. And there are your 3 pieces. Okay, so that's it for piecewise functions. Next video we'll start on absolute value functions, which are, yes, not any more fun. So anyway, wait for that.